Hey everyone, and welcome back. So today we're diving straight into Chapter 10, Lesson 3. We've got a really fantastic explainer for you where we're going to totally unlock the secrets behind three very specific, very important types of angles. If you've ever, stared at intersecting lines and wondered about the math hiding in all those spaces, well, you're exactly in the right place. Let's get right into it. Okay, here's our game plan for today. First up, adjacent angles. Then we'll hit complementary angles. Follow that right up with supplementary angles. And finally, we'll wrap up with a little practice time to really lock it all in. All right, kicking things off with Section 1, adjacent angles, or as I like to think of them, angles that are placed right next to each other. In everyday life, the word adjacent just means next door, right? Like neighbors. But in math, well, being a neighbor comes with a few strict rules. So for two angles to actually be considered adjacent, they have to check off three specific mathematical boxes. Number one, a common vertex, meaning they literally have to share the exact same corner point. Number two, a common side. They've got to share one of the actual line segments that forms the angle. And number three, zero overlap, none. They have to sit perfectly, neatly, side by side. Let's picture what that actually looks like with a perfectly valid pairing, like angle QMO and angle OMZ. Notice how they both meet right at that exact same corner point, M? That's our common vertex. And right there in the middle, they share that line segment, MO. That is our common side. They're basically perfect neighbors. But, on the flip side, think about an invalid example. Two angles may sit super close to each other, but if they are missing that shared common side, well, because that boundary wall isn't there, they completely fail the test. Now, I really want you to remember this because it's a super common trap. Just having a common vertex is absolutely not enough. Seriously, you can have two angles touching at the exact same point, but if they don't share that dividing line, that common side we just talked about, they're definitely not adjacent. You absolutely need the shared corner and the shared wall. Moving right along, let's shift gears from visual shapes to some basic addition with Section 2, complementary angles. This brings us to the 90-degree rule. Okay, I want you to mentally highlight this number right now, 90 degrees. When we talk about complementary angles, 90 is literally the magic number. Whenever you hear the word complementary, your brain should instantly picture a giant glowing 90-degree sign. And here's the rule. It's super simple. Complementary angles just mean that if you take angle 1 and add it to angle 2, their total sum is exactly 90 degrees. Honestly, it doesn't even matter what the individual numbers are. As long as they sum up to that perfect 90, you can confidently say, yup, those are complementary angles. Let's put that into perspective with a quick example. Imagine we have two separate slices of a circular chart. One slice is 25 degrees, and the one right next to it is 65 degrees. Well, do the math. 25 plus 65 equals exactly 90. Put them together, and they form a perfect quarter circle, a perfect right angle. Because that total hits exactly 90, we know for sure that these two are officially complementary. All right, let's step it up a notch to Section 3, supplementary angles. The 180-degree rule. If complementary was all about the 90, we are doubling down here. So burn this new number into your memory, 180 degrees. While 90 gives us that sharp right angle corner, 180 is really special because it flattens out into a perfectly straight line. When I say supplementary, I want you to immediately visualize a straight, flat line and the number 180. The formula here works exactly like the last one, just with a new target. Angle 1 plus angle 2 has to equal exactly 180 degrees. If you take any two angles, put them together, and they hit that 180 mark perfectly, they are supplementary, period. They will always stretch out and form that flat line together. Let's see this in action. Say we have a really big angle sitting at 130 degrees and a smaller one right beside it at 50 degrees. Add those up in your head. 130 plus 50 gives us exactly 180 degrees. And when you combine them, their bases lock together to create a perfectly straight, horizontal line cutting right across. That straight line, that is the absolute dead giveaway for supplementary angles. Okay, Section 4, it's practice time and quick revision. You guys have totally learned the three big rules, so now we're going to do a rapid-fire quiz just to make sure all of this is fully locked into your brains. But right before we jump into the questions, let's do a really quick recap. Think of this as your ultimate cheat sheet. Here we go. Adjacent angles, they need a common vertex and a common side. Complementary angles, their sum is exactly 90 degrees. And supplementary angles, their sum is exactly 180 degrees. Make sense? Awesome. Let's get to the quiz. All right, first scenario for you. You've got an angle of 30 degrees and another angle of 60 degrees. Add those up real quick and tell me, what type of angles are we dealing with here? If you just yelled complementary angles at your screen, you nailed it. 30 plus 60 gives us a perfect 90 degrees. And as we know, that magic 90 means they are absolutely complementary. Awesome job. Let's level up for the next one. Okay, slightly bigger numbers this round. We've got 110 degrees and 70 degrees. Do the math in your head. What type of angles are these?
Spot on. Those are supplementary angles. 110 plus 70 brings our grand total to exactly 180 degrees, which creates that perfectly straight line we were talking about earlier. Brilliant. All right, let's do one last question, but I'm going to switch gears away from the math for a second.
Listen really carefully to this one. You've got two angles. They share a common vertex, and they share a common side. No overlap. What kind of angles are they?
You got it. They're adjacent angles. They totally pass the neighbor test, sharing both the corner and that dividing wall. You completely crushed this practice round. Seriously, well done.
And honestly, just like that, you've mastered all three angle types. But you know, math isn't just stuff floating around on a screen. It's literally everywhere in the architecture around us.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.